Hi everyone, we are looking at our last learning target for this unit, which is 2.3.4. So we are on page 35 in our note packet, and we are trying to figure out if two equations that were given, so two lines, if they are parallel, perpendicular, coinciding, or intersecting. And so we want to use what we learned in 2.2.4 about what parallel lines have in common and what perpendicular lines have in common, so on and so forth. So we are going to go through the video notes section, and there are two examples that we're going to walk through together. So to be able to compare linear functions, we have to be able to compare their slope and their y-intercept, their b values, because that is what was so important in the notes from 2.2.4. So to be able to compare linear functions, we need to know the slope, which is their m, and the y-intercept, which is the b, for both equations. So we need to figure out what the slope and the y-intercept is for both equations. And the easiest way to do that is to manipulate the equations so that they are in slope-intercept form. So we want to get them into y equals mx plus b, so that we can easily see the m value and the b value for those. So for the first example, we have two equations, and we're going to walk through them together. So it says, determine if the following lines are parallel, perpendicular, coinciding, or intersecting. So for the very first one, I'm going to put a little blue dot because I'll do the work in blue for that one. If we look at that, we have 2x plus 4y equals 4. That is not in slope-intercept form. So we are going to have to manipulate it. We want to get y by itself so that we can have mx and b on the other side of the equal sign. So I'm going to rewrite it right on this side. So we have 2x plus 4y equals 4. And if I want to solve for y, I have to move everything away from it. So I want to move away my 2x. So I'm going to subtract that from both sides. And normally, if we look back up here, our mx is usually first and then our b is at the end. And so even though I'm subtracting it, I'm going to put it kind of in front of that 4. So these will cancel. We're left with 4y equals negative 2x and then our positive 4, so plus 4. My y is not by itself yet, so I want to divide everything by 4 so that I do get y by itself. So I want to divide this by 4, this by 4, and this by 4. And I'm actually going to rewrite it next to this equation because I ran out of room. So 4 divided by 4 is 1, so this ends up being like 1y or just y, so I get y. I have negative 2x divided by 4, so that's negative 2/4. And I can actually simplify that fraction. So if I have negative 2/4, I can divide both the top and the bottom by 2. And so that turns into negative 1/2 or negative 1/2. So I have negative 1/2 x, which was this part right here, plus 4/4. 4/4 simplifies to 1, so plus 1. So now this is in slope-intercept form. This is what I want to compare with my second equation. So for my second equation, I'm going to use pink, and I look at y equals 2x minus 3. That one is in slope-intercept form, so I don't have to change anything at all. So I first want to look at my slopes, and that's going to help me figure out the rest. So my slope for my first equation in blue is negative 1/2, and my slope for my second equation in pink is a positive 2. So automatically, I know my lines are not parallel because if they were parallel, they'd have the same slope. I know they are not coinciding because if they were coinciding, they'd also have the same slope. So they're not parallel, they're not coinciding. So it's either perpendicular or intersecting. Perpendicular, if we think back to the last lesson, is when we take a slope and we do the opposite sign and the reciprocal. So this is positive and this one's negative, so they are opposite signs. 2 is technically 2 over 1, and the reciprocal of that is 1 over 2. So these are opposite reciprocals for the slope, which means I don't really need to look at my b value. These are perpendicular. I'm going to put a little cloud around that because they are perpendicular. Nope, my R is kind of funky. So for the second problem, very same thing, but it is worded a little different. So it says, what is the relationship between the lines 5 parentheses x minus 1 and parentheses equals 15y and y equals 1/3 x minus 1/3? So I'm going to do the same thing. I have to make sure they are both in slope-intercept form. So starting with the first one, if I look at this one right here, it is not in slope-intercept form. And so I want to get rid of my parentheses because slope-intercept form does not have parentheses. And then I do want y by itself. So I'm going to rewrite this one over here. And then I'm going to distribute my 5 to everything in the parentheses. So 5 times x is 5x. 5 times -1 is minus 5. Then I can bring down my equal sign and my 15y. My y is not by itself, so I want to divide by 15, which means I have to divide everything by 15. And so I'm going to have a fraction 5 over 15, which I can divide the top and bottom number by 5. And so I end up with a fraction of 1/3. So I have 1/3 x minus, and then 5 over 15 would still be 1/3, equals, and then 15 divided by 15 is y. If I wanted to rewrite this so my y was out in front, that's fine, but I have mx plus b, so my m is this 1/3, and my b is this -1/3. So looking at my second equation, this is already in slope-intercept form. I have an m in front of my x, and I have a b at the end there. And if I notice, it's the same equation. I have the same m and the same b, which means these lines are coinciding. So if we were to graph them, they would be graphed right on top of each other, like completely, and so it would look like one line because they are the same equation. So the goal for this is to put it in slope-intercept form so we can easily compare the slope and the y-intercept, so the m and the b. So you guys are going to do the independent practice that's at the bottom. If you need extra help, there is the extra help video as well.